Hello friends, welcome to Lucky Gate. This is a question asked in GATE 2017 for 2 marks and from the subject database management system, and this is a numerical type of question, so we have to fill the blank. Now coming to the question, two transactions T1 and T2 are given. Now what is T1 given? T1 is reading and writing the value of X, similarly reading and writing the value of Y, and what T2 is performing, reading and writing the value of Y and reading and writing the value of Z. Now coming to the question, Ri of Y denotes read operation and Wi of Y denotes write operation by transaction Ti on a variable V. The total number of conflict serializable schedules that can be formed by T1 and T2 is, that is a question. How many conflict serializable schedules? That is a question. And friends, you can solve this question by writing all possible concurrent schedules over T1 and T2 and check for conflict serializability by constructing the precedence graph. So this will take more time, but how to solve this one in a simpler way? Now see, T1 is executing with X and Y data items, T2 is executing with Y and Z data items. It does mean that Y is common for both T1 and T2. If any conflict possible, that conflict you can expect between only with respect to Y of T1 and T2. Now see, instead of finding number of conflict serializable schedules, I need to find number of non-conflict serializable schedules. Why? Because the number of conflicts possible with respect to T1 and T2 with respect to the data item Y is less, so that it is better to find non-conflict serializable schedules. So before I explain you how to find non-conflict serializable schedules, first we'll see how many concurrent schedules possible over T1 and T2. So here I am writing the number of concurrent schedules possible equals 4 plus 4 whole factorial by 4 plus 4, because 4 and 4 are the operations of T1 and T2 respectively. 4 factorial into 4 factorial. When you solve this, you will get 70. So means the total number of concurrent schedules are 70. Among the 70, how many are conflict serializable schedules are the question. Now, to find non-conflict serializable schedules, I need to find the possibility of a cycle in the precedence graph. The possibility of a cycle in the precedence graph occurs if there is an edge from T1 to T2 and T2 to T1. So to have an edge from T1 to T2 and T2 to T1 between these two operations, if R2Y comes, it won't cause any cycle, but if W2Y comes, now it will cause a cycle between R1Y, W2Y and W2Y, W1Y. This is one possibility. Another possibility is between R2Y and W2Y, if W1Y appears, so that it causes a conflict, R2Y, W1Y and W1Y, W2Y. So it causes a cycle. So there are two cases for possibility of a cycle. Now each of the case I am going to explain clearly. Now I am calling that is case 1 and it is case 2. Now what is the first case? T1 and T2. In the first case says the W2Y should appear between R1Y and W1Y. Means these are the operations of T1, R1X, W1X, R1Y and W1Y. Between R1Y and W1Y, what is required to have W2Y to cause a cycle? So that R1Y, W2Y is a conflict. You can expect an edge in the precedence graph from T1 to T2. Similarly from T2 to T1. Because a cycle is possible, it is causing a not conflict serializable schedules. Now observe friends, before W2Y, what is possible in the T2 transaction? R2Y. After W2Y, what is possible in the T2 transaction? R2Z and W2Z. Now, see here, I am treating this problem as two problems. One is in the upper part, this one is in the bottom part. In the upper part, the 3 operations of T1 and 1 operations of T2 appears in any number of ways, it is not going to form a cycle. So that number of ways the 3 operations of T1 and 1 operations of T2 can be arranged in 3 plus 1 whole factorial by 3 factorial into 1 factorial possibilities, which is equals to 4. Similarly, in the bottom side, 1 operation of T1 and 2 operations of T2 can appear in any number of times, so that it not causing any cycles. So that number of possibilities are 1 plus 2 whole factorial by 1 factorial into 2 factorial, which is equals to 3 possibilities. Means in the upper side we have 4 possibilities, in the bottom side we have 3 possibilities. Now the total number of non-conflict serializable schedules are equals to 4 into 3 possibilities, which is equals to 12. Now similarly, you have to check for the case 2. In the case 2, you have 2 transactions, T1 and T2. What case 2 says? The W1Y should appear between R2Y and W2Y. See, what are the T1 operations? R1X, W1X, R1Y, W1Y. Between this W1Y means W1Y should appear between R2Y and W2Y. Now observe friends, what you can expect after W2Y? R2Z and W2Z. And here also I am treating this problem as 2 problems, where one in the upper part, one in the bottom side. Now look, in the upper part, these 3 operations of T1 and 1 operations of 2 can appear in any number of ways. It won't cause any conflict. Similarly, this bottom part treated as separately. Now here, because I am arranging this W1Y between R2Y and W2Y, so it causing a conflict from R2Y to W1Y and W1Y to W2Y, causing a cycle. Now the schedules possible with this arrangement are called non-conflict serializable schedules. Now we'll see how many possibilities in the upper side. The similar way we solved case 1, we will solve case 2 also. Because T1 is having 3 operations, 2 is having 1 operations, the total number of concurrent schedules possible is 3 plus 1 whole factorial by 3 factorial into 1 factorial, which is 4 possibilities. In the bottom side, there are no operations in T1 side, we call 0 operations, and 3 operations in T2 side. So the total possibilities are 0 plus 3 whole factorial by 0 factorial into 3 factorial. Friends, you remember 0 factorial is 1. So that is 3 factorial by 3 factorial. This is 1 possibility. Now here, the total number of non-conflict serializable schedules are 4 into 1, which is 4. Now the question is to find the number of conflict serializable schedules. In the case 1, we have total possibilities 4 into 3. In case 2, we have total possibilities are 4 into 1. So the total of case 1 and case 2 non-CS schedules are 12 plus 4, which is equals to 16 possibilities. Because my question is about CS schedules, means conflict serializable schedules, so I can say total number of conflict serializable schedules are equals to total concurrent schedules minus total non-CS schedules. How many? 16, which will give you total conflict serializable schedules, that is 54. So 54 is the answer for the question. I feel it is worthwhile question for 2 marks, and this is the kind of questions you can expect it. So please like, share and subscribe, and don't forget to click the bell icon so that you will get personalized notifications, so that you are not going to miss any of my uploads. Thank you.